Hi, everyone. My name is Cecilia Dome, and welcome to our CTS Lab Research Coordination Network lunchtime webinar series. And I'm very delighted to have Josh today, and I will invite our steering committee member, Michael Bobker, to introduce our speaker. Michael is also our co-PI for the RCN project. Michael.
Thank you, Cecilia. Hi, everyone. Thanks for being here. It's really a pleasure to introduce Joshua Foss to speak to us today. I've been involved in energy for many years, and through that, sustainability. So I've heard lots about sustainability designers, but Joshua is truly a sustainability designer. Doesn't produce the things that we're used to in a sustainable way. He actually creates sustainable processes, design sustainable processes. It's fascinating. He has emphasized a concept of net positive level of performance. So not just reducing our footprint, but actually regenerative efforts to bring the planet back to a point where we might like it to be. He's done multiple of these regenerative assessments in cities and regions. He's been an advisor to Fortune 5 companies on community safety and regenerative design as part of their corporate sustainability practices. He has presented at the United Nations and at global entrepreneurship summits. He has been recognized as an emerging innovator by the Ellen MacArthur Foundation Circular Economy 100 network. He's co-produced several conferences on regenerative economics and developed a groundbreaking online master's course on sustainable product service innovation. And of course, he's been a principal planner on multiple district infrastructure designs that have gained recognition across the country. He has a master's degree in strategic leadership towards sustainability. He's a certified permaculture urban farmer. And this is a new one to me, but I think it has very interesting potential. He's a credentialed crime prevention through environmental design specialist. In these days of defunding the police, looking for new ways to police, that certainly sounds interesting, and maybe we'll hear about that one in the future. But for today, it's food networks as the core. And Josh, it's my pleasure to turn it over to you.
Well, thank you, Michael and Cecilia. That was a very, very thorough introduction. Yes, so it's a pleasure to be able to have the opportunity to speak to everyone on the call right now. So my understanding is that this theme is really around food, energy, water nexus. So this specific presentation is really going to be focusing on the food piece of that, and then make linkages to energy and water as well. So, with a bit of background, I'm going to kind of dive in and let's see, there we go. So a little bit of a kind of background on this presentation. Really, the purpose is to take a bit of a high level kind of integrated ideal examination of what a net zero food system and localized food system could look like. There's been a number of efforts out there who, often have pretty dramatic implications on future diets where, everyone has to be a vegan, or there's going to be these huge vertical towers growing all our food in these urban centers. And that's not really the direction I'm trying to do with this presentation. It's more acknowledging from what science is telling us today, what is a healthy, balanced diet? And ultimately it's what this, the presentation is going to be examining what type of production methodologies that are already tested and proven today can be utilized and scaled in different ways to create a very kind of integrated food system that can create food security. And much of this work is building on a a past research project, and it's actually continuing. It's the American Institute of Architects Gowanus Net Zero study that is examining that district in Brooklyn, as being very self-sufficient. So some earlier examination and modeling and workshops took place, late last year and into this year. And I'd led the food team analysis of that. So this is an extension of that analysis. So a bit of background on the specific focus areas. This is a rendering of the Gowanus district, which is about 600 acres. And the canal, of course, is going right through there. The current population of 2019 is a little over 17,000. And through pretty ambitious rezoning and some projected kind of growth and added density, they're projecting that there'll be about 55,000 people by 2050 in this rezoned area. Concurrently thinking at a much larger foodshed region, which I'll be making that connection to. It's examining essentially how much land and processing would be required to be able to support the entire population in New York City, about 8.77 million people. So some of the numbers that will utilize the acres of farmland within the New York Hudson Valley food sheds, about 730,000 acres that will be examined. There's, of course, thinking about the 150 mile perimeter certainly extends into New Jersey and Connecticut as well. So this is just informing kind of the analysis. So to start this examination, I really was just curious, what's a healthy, balanced diet consist of? And ultimately, this is informing what type of food do we have to produce to be a completely sufficient food system. So this is from the American Heart Association. Probably seen different versions of this before. Different servings per day, just spread out across a lot of different food components and ingredients. So taking that into kind of a volume metric, essentially calculated servings per day into actual weight of food and calories that are attributed to that. And this is pretty consistent. Generally, they say, average person eats between 3 and 4 pounds of food a day. Calories range a lot. So these are all healthier, lower calorie options that are recommended for us to sort of get us to that 2,000 calorie diet. So projecting that to the populations that I walked you through, Gowanus current, Gowanus projected, New York City current, sort of shows an indication of how much food needs to be produced across all of these areas. So really large volumes. We're talking about 2.5 billion pounds of vegetables and fruit, on an annual basis. So some pretty notable sizes. So with that as a context, the examination is well, what type of food production processes are happening out there? What are the precedents that we can learn from? And how productive are these systems, across a number of tested cases? So, the examination looked at essentially the productivity of different systems at pounds per square foot. So looking at community gardening, certainly much more specialty on kind of heirloom crops, hyper-local production, small-scale organics. We're looking at a little less than a pound per square foot of production. The Brooklyn Grange rooftop farm, which essentially is taking the same intensive soil-based process and putting it onto the rooftop, has demonstrated slightly less productivity. Just more space, harder to have it be very intensive. Shifting to some other methodologies, we're getting into hydroponic greenhouses. So this is rooftop based, where you're able to still use the solar energy. So it's not a completely enclosed, artificially lit environment. So it keeps the operating costs substantially down, but you're able to activate the verticality of that. Gotham Greens and Whole Foods in Gowanus was a case study, and Lufo Farms has a few facilities. So looking at their production capacities, they're substantially more than what you can grow on the ground at 8 pounds per square foot. Taking that up to the next level, looking at vertical farms like the Arrow Farm in Newark, and a few other concepts, the pictures on the bottom, to the right and the bottom right, demonstrate just how much vertical activation you can have from these processes. So we're getting close to 30 pounds per square foot, which is pretty noticeable compared to a ½ pound to 0.85 of soil-based. Now, thinking beyond just the urban core into more of the food shed, looking at the Dutch model, which has become a global precedent as far as how this very small, pretty populous and landlocked country could be the #2 exporter of agriculture products in the world behind the US. It's because they rely heavily on controlled environment agriculture, which, similar to the rooftop, it uses natural light and complements it with artificial light, and it just has a tremendous amount of productive capacity. So here in the Northeast, there's Bright Farms. There's also, of course, a lot of precedent in Holland. So we're looking at about 14.5 pounds a square foot. And these numbers are preliminary. They're not super polished and validated. It's just looking at what precedents are available. Also thinking more along the lines of productive systems, getting into aquaculture. So thinking about fish, seafood production, a few precedents, and they're looking at about 30 pounds per square foot. And another precedent that seems certainly worthy of attention is looking at more biodiverse, regenerative, organic regional farms, and looking at these as ways to fulfill a lot more of the diverse crop needs, supporting even the meat and dairy, eggs, and we're starting to see more even regional grains, which can be grown through organic means. So looking at some of these precedents, we're seeing dramatically lower yields, but of course these rely on just much larger areas of land. So you can see some of the metrics down there. So basically using this as a foundation as far as, okay, what can we draw from? And when we're designing a food system for Gowanus and for New York City, how do we fit all these different approaches to size to achieve our goal of being a completely food shed secure community? So basically evaluated these technologies and processes and prioritized them, particularly from a Gowanus standpoint. So priority here is to really optimize the vertical farms. And of course, you're only growing a few select crops here, microgreens, baby greens, and herbs. So it's going to be not a huge portion of what our vegetable consumption by volume would consist of. But if we're able to maximize that and really celebrate the nutrient value of having foods be grown so close to our communities, within our communities, we can look at how that might be integrated within the urban fabric. So, if we're looking at 10% of total vegetable consumption, we'd need, you can see the projected demands here for the 3 typologies, and surprisingly how small the footprint would be to be able to grow this much food. So for current Gowanus, we'd need about ½ of an acre to be able to produce this much vegetable, these microgreens and baby greens. And for all of New York City would be about 200 acres, which it's not a small area, but if you're thinking about the production scale of even Arrow Farms right now, which is about 100,000 square feet for just one facility, we'd need just a handful of those to fulfill the entire city. So the second priority would be let's think about how we can use the soil and the land within our urban core for production. And of course, we're going to grow a much greater variety of foods here, but we also have to be very considerate of like the other real estate and productive value functions of land. We can't say half of all land is going to be for agriculture in New York City. So being realistic about how we can, allocate and prioritize, and again, think about, food production as a community asset and for very hyper local heirloom products and supporting direct market. So a target that established here was 10% volume of vegetables and 5% for fruit. And you'll see noticeably much greater supply for land. For 20 acres, for that same amount of vegetable compared to half an acre for the vertical farm. And that would take about 3.4% of the land area currently within Gowanus. Obviously land areas stay the same, but with increasing the density threefold for the 2050 projection, it's going to take a much larger amount of land to be able to provide even this small amount of food for the community. And broader New York City sort of bridges that gap from a FAR density area. The third priority is looking at the higher productivity rooftop controlled environment agriculture greenhouses, like the one on the Whole Foods, or the one that Bright Farms has developed, or Lufa Farms has developed. So the projection here, again, being sensitive of not using every rooftop space, but just thinking about other potential values, we're targeting 20% total veg consumption by volume. And you can grow quite a bit of food in these greenhouses beyond just the microgreens and leafy greens. You can get into tomatoes and peppers and cucumbers and eggplants. You can have quite a bit of diversity there. So to support that demand, we're looking at about 2.9 acres of roof coverage for Gowanus as it is, 9 moving into the future, and about 1,450 for all of New York City, which would be about 0.8% of the entire land area, which is still a large amount, but this is getting into much greater volumes of food security through this approach because of its increased productivity. Priority 4 is looking at seafood production. So if we had one of these recirculating aquaculture systems within the community, we could grow about 80% of the demand for fish and seafood on very small space. So thinking, quarter of an acre for Gowanus, about a 10,000 square foot facility. New York City, obviously much bigger, about 120 acres, which would probably be best served spread across multiple facilities. Priority 5, getting into the regional, beyond just the district and into the bioregion. Obviously, we've only covered about 40% of vegetable production thus far, maybe 15 of fruit, much higher in the seafood capabilities. But there's still a lot of the diet of our food needs that are unmet. So that's where we need to look into the foodshed, the regional farms and production more directly. So again, this idea is really looking at that Dutch model as a precedent, and increasingly regions in the US are looking at that as a precedent to extend the seasons into the 4 seasons. You have far less pesticide and water use. And so the environmental benefits are really notable. And the key point that I'll stress in a few minutes is that through this greater production of the massive volume of produce that will go to a community's market, you can actually free up space that's conventionally used for more monocrops and cultures for much more productive ecosystem services. So the way that I'm envisioning, becomes an increasingly central facet of regional foodshed systems. So looking at the sort of land use implications of 50% veg consumption by volume and 30% of fruit, we'd only need an 8.5 acre greenhouse, or it's spread out across a couple of greenhouses for Gowanus as it is today. So it's a pretty small facility, thinking within the broader region. And then certainly getting into the bigger New York City metro, 4,000 acres seems like a lot, but my understanding is there's about like 850,000 or so acres of farmland that's currently within the Hudson Valley foodshed that's currently used as farmland. So this is a very, very small percentage of that. And then the last priority is really relying on these regenerative organic farms to backfill all the other needs that hadn't been met yet, and do it in ways that enhance biodiversity, that provide much broader ecosystem services, and ultimately can utilize livestock constructively so that degrees of meat demand could be met, and they provide tremendous value within kind of a regenerative farming model as far as being a critical part of the carbon cycle and nutrient cycle with their fertilizers and composts. So you'll see here the targets are spread out much more. We're going to try and cover pretty much the distance between veg and fruit. Fruit relies much more on orchards and trees, so that of course is better suited in soils than in greenhouses. We're getting into the full dairy coverage. And this was actually quite interesting, but even evaluating kind of the grain potential, nut seeds and beans, that those could be met within regional farms as well, that there is production capacity and these could be scaled up to support the dietary needs that were outlined earlier. So productive capacity is much lower for some of these other areas, but looking at the acreage needed for grains would be 230,000 acres. So much bigger than anything we've looked at thus far. So basically a summary of findings as far as like what this kind of integrated evaluation of different production methodologies, certainly idealized. It's not fully covering a lot of the economics, that was a consideration, but the, and subsidies and some of these other agriculture related themes were not fully addressed in that analysis, but basically, examine that there's a tremendous opportunity to cover a notable amount of food within our urban core, and then relying on these far greater productive processes within the regional farms, we could more than meet our local needs through the foodshed here, even as the most dense metropolis in North America. So the strategies that were outlined, not including full livestock evaluation, was a little over half of how much farmland is already being used today. So it seems like there is a lot of viability in what this model could do. But again, the key strategy is stressing reliance on these regional greenhouses to be able to provide kind of the heart of the produce volume that would go to grocery stores, our restaurants, and some of the other food retailers. Additional consideration, the New York Metro, of course, is much larger than just New York City itself. So the foodshed would need to account for that bigger population, but we're also looking at a bigger catchment area of farms that could include New Jersey and Connecticut within that analysis as well. So that's kind of part one of some of the analysis. And the second part is looking at, what are integration strategies and opportunities, both from an urban context and from a regional context. And, even trying that on for the Gowanus district concept. And one thing that was really examined as a priority in some workshops that we did back in December was this idea of a food hub. And so a food hub would essentially be a community-based production and distribution facility. And this could serve as, a neighborhood destination that has, markets in it, but certainly first and foremost, it's a place where a lot of this production could take place. And the regional food that would be coming in from these the broader food shed could come and drop these food items off and have them be packaged and processed and then prepared for distribution to the community itself. There can be meal preparations and additional functions of community benefits like retail and education, and utility functions based off of the amount of metabolic processing that would be taking place here, to include waste energy, biodigestion, so on and so forth. So some analysis building on an actual project that I was working on a few years ago, I actually did some kind of custom modeling of what would a specific food hub based off of Gowanus 2050, what type of functions and scales would that look like from even a schematic design standpoint. So this is a facility. You can see a kind of a rough rendering on the upper right, which demonstrates the scale and even a bit of the verticality. There'd be 4 or 5 potential levels of productive opportunity happening within this type of facility, including potentially underground biodigestion, which would absorb a notable amount of the community's food waste and other organic waste that could be co-digested and converted into renewable energy on site. There's also a pretty sizable water treatment facility within this space. And you can see about a 50,000 square foot space for food distribution, drop-off, processing. Also within the facility on the first floor would be some of the digestion equipment, including blending, hydrolysis, that essentially would feed into the digester itself. The third floor above that would be much more on the vertical farm production and the aquaponics. And this would be a facility scale to support the entire population's seafood and fish needs for 2050. And the, similar as I modeled earlier, the microgreens and leafy green production capacities that would be required within the community as well. And then up on the roof, there would be the controlled environment agriculture hydroponic facility, which would have more of the Gotham Greens type of approach and grow a wider variety of foods, leafy greens, and not contribute to the same degree of food security within the community there, but have a sizable production there. So that was just kind of some rough schematic modeling as far as like what type of scale would a facility look like. And again, building footprint of 100,000 square feet demonstrates there's a tremendous amount of production potential within this type of industrial facility sited in the urban core. And then expanding the idea of integration into the bioregion, into the regional farms. A bit of context is that the average size farm in Hudson Valley is about 135 acres. And there's over 5,000 of these farms within the New York-based Hudson Valley food shed itself. So imagining an average 135 acre farm that's likely used for more monoculture type of production, re-envisioning that to include a lot more diverse integrated crop, livestock, and landscape functions, similar to what I included in the presentation that could all be done on a single site. So this is very preliminary analysis. I'd love to do some deeper analysis as far as the economic and productive analysis of these different functions. but the same 135 acre parcel envisioned that a 5 acre greenhouse could go on this. Not a large piece of that, but again, having tremendous amount of productivity on far less land, which then frees up more land, let's say presumably 50 acres, for diverse regenerative farming functions to be able to get, a lot of those produce grain needs met within the region. Additionally, we're starting to hear more about agrivoltaics and other renewable energy potentials on how farmers are starting to use their land. And if we allocate 20 acres for solar, we could produce between $425,000 and $850,000 of new profit every year from this farm. And I didn't mention that for the organic farm, just from the soil benefits of no-tilling and the carbon sequestration capacity, some data show that each acre of a regenerative farm can absorb about 760 tons of carbon. So that's 38,000 metric tons a year, which at about $10 a ton in a higher quality carbon market would create close to $400,000 of revenue a year. And then with the remaining 70 acres, imagine what other productive functions we could have, from reforesting, increasing biodiversity, having sustainable timber production that could support maybe cross-laminated timber industry for the built environments. And then there's additional credits that can be captured through carbon conservation and water quality markets as well. So just thinking, out of the box about, how, a land scale of this nature could have multiple revenue generating and ecosystem services within a single site. And obviously it requires a lot of disruptive thinking within policy and economics, but some greater analysis as far as, what some potential incentives and mechanisms to further initiate some of these market forces would be really interesting to do. So that essentially summarizes my wild ride of what an ideal integrated food system could look like for Gowanus and New York City, and would welcome any questions, comments that you have at this point. Oh.
Thank you, Josh. I know that we have Nuri Martinez has posted, she will be handling the question and answer, and you can email your questions to her directly, privately. We did have a couple of questions that came up in the chat. So I guess we can start with those.
Great.
Josh, when you talk about square footage, are you considering, is that an all-in square footage number? Does it take into consideration the circulation that's necessary as ancillary to the direct productive area, or is that just direct productive area?
My understanding is it's predominantly direct productive area, yet particularly in some of the urban systems, but a lot of the references were, for a greenhouse, for example, would say, it's 100,000 square foot facility that produces 1 million pounds of produce a year. And so, it wasn't clear to me what degree of kind of ancillary functions would be included within their, the analysis they would have. But my understanding is that would likely include the necessary kind of processing equipment, any office space, things like that. It's not just only the technical equipment itself. But from the regional standpoint, similarly, it's, the evaluation, just like how much production can happen on this scale of a farm or a process. And that would presumably include a lot of the ancillary functions as well.
Okay, thank you. And that question came, by the way, from Hillary Brown. For those of you who aren't looking at the chat, from Hillary Brown of City College of New York. Hillary, thank you for joining us.
Yeah, this is awesome. Thank you, Josh.
You're welcome. Now, how do we do this?
Yes. This presentation really has a lot of possibility to, to go upstate,
Yeah.
as well as downstate. I'm going to think about this a little bit more, but I think you could really take this to organizations that are very interested in the Hudson Valley.
Fantastic. Yeah. And this of course, is just a very preliminary kind of launching pad. And I would love to do some deeper analysis. And honestly, an ideal would be taking even a conventional farm and thinking about bundling all of these or stacking all of these different production and ecosystem functions and making that a bit more kind of fleshed out and granular as far as what that could look like, what the economics would look like, what the market potential would be. Essentially doing like a light feasibility of that concept would be, I think, really, really meaningful.
We will talk about that. That's an excellent prospect.
I would love that. Thank you.
For some student work.
Great.
So we do have a logistical question from Marieke Santema about whether the recording will be available. Cecilia, perhaps you can comment on the recording and its availability.
Yes, all the webinar series will be recorded and they are going to be available on the urbanfuel.net website. So the link is with the, yes.
So another question from Josh Sperling. Josh is the National Renewable Energy Lab. The question is about land from the Port Authority and use of our amazing inventory of abandoned shipping containers, whether those might provide a kind of climate-controlled freight-based environment.
Yeah, fantastic, Josh. Love that you're on the call. Nice to hear from you. It's a great question. We're certainly seeing a lot more, particularly in the urban context, production within these shipping containers. My understanding, I haven't done a very thorough analysis of them, is that the scalability of them are pretty difficult. That their operating costs from an energy standpoint, even from a labor standpoint, is really high. And so you have to create very specialized products and crops like microgreens or very specific things to have the economics work out. That it's just not a very scalable type of solution to think about the broader volumes of these kind of basic food items that would need to be produced and brought to market. But certainly a lot of innovation in that space. So I think what they're able to demonstrate is just showing how productivity can occur in much smaller, more unconventional spaces, and that can inform the potential implications for growing food in basements or in smaller buildings, so that there's even much more distribution of production throughout the built environment.
So it seems that we skipped over the private questions and went straight to chat. So Nuri, I'll let you pick up anything that was in the private chat to you questions, and and then continue with the questions in the public chat. You can pick up if you would like.
Yes, thank you very much. So I have a question from, it's more of a comment, Wesley Schwank, mentioning that the Kroger Co. and Infarm, a Berlin-based urban farming network, announced a first of its kind partnership in the United States that will bring modular living produce farms to Kroger's QFC stores in Washington State. I don't know if she wants to, she wanted to mention something, but I'm not able to unmute. Wesley Schwank, please, Cecilia, if you could.
Let me see.
Wesley Schwung, okay.
Wesley, you should
Can you hear me?
Oh, yes.
Yeah, I just want to mention there's a difference between on-site and off-site vertical farms, right? That's it.
Okay. On-site and off-site vertical farm.
Like if something is, if the vertical farm is at the point where customers can get their produce from, it's probably on-site. It's not a technical term that somebody came out with. It's just what I perceive as.
Yeah, no, I think that's a fair differentiation. So like an Arrow Farms in Newark, New Jersey would be an offsite since they don't have a market that you'd be able to go to and get their the food items from there directly. So I think that's also the value of having a food distribution hub is to be able to collect all the food produced from all these diverse applications and facilities and processes and being able to get them distributed very quickly to the community itself.
Thank you. We have another question from Josh Sperling. The question says, perhaps land available by a Port Authority of New York.
Asked that question already, Nuri.
I'm sorry. I was reading the other questions before. Sorry about that.
So Masood Gandhari, Masood, you had a question about incentives that you wanted to ask?
Yes.
Yeah, thanks, Josh. This is Masood from NYU.
Okay.
So when it comes to the urban scale version of what you mentioned, so what are some of the current, policies and incentives that is perhaps going to enable this vision? Would it be a government driven? Would it be a private sector driven? What are some of the channels by which you can kind of imagine realization of what you presented?
Yeah, fantastic question. And very complex. It's different in every community as far as just what the policy environment supports. Generally, my understanding is that a lot of the more like indoor processes, thinking about the rooftop CEAs or the vertical farms, those are predominantly private driven. So these are ventures that are more or less procuring the real estate themselves, and they have a business case for producing food and having a market for it. So there isn't a substantial inhibitor to that right now. The bigger inhibitor would be on more of kind of the land-based or even potential rooftop soil-based type of production, which the regulatory environment can often stifle community farms and what can be grown in soil, what can be marketed, just a much higher regulatory environment. Mm-hmm. And then certainly just the real estate value of growing in the soil right now at those much lower productive yields, it doesn't really pan out in an urban environment, particularly in New York City, where an acre is tens of millions of dollars. Mm-hmm. So obviously if we wanted to hit these type of targets, then the incentive structure would have to shift quite a bit. But that's also why, I'm pretty conscious. It was just let's not go too heavy into this type of production, acknowledging these limitations and knowing we could likely have a much bigger impact within different type of production processes that happen outside of the urban core itself. Where you don't have to hit those barriers, run into those barriers as aggressively.
Good, thank you.
Yeah.
I have a question from Roberto Rojas. Two questions for the speaker is, what are the demands of water and energy by large greenhouses? And the second question is, are greenhouses cost effective at this time, or are there technologies needed?
Great question. So certainly kind of energy and water would be higher operating expenses for these more urban processes facilities, particularly for the vertical farms that are not drawing natural light, like the rooftop facilities or the controlled environment in agriculture. So the energy is a really big expense for them. And that's been a key barrier for why there hasn't been greater uptake of these technologies in the urban center. And, water is certainly expensive, but, generally, in the States, like water is very affordable. And the beauty of a lot of these processes, they're pretty water efficient. They're recirculating and reducing water by about 90 to 95% compared to conventional approaches. But that's also thinking about the integrated food hub. If it has waste to energy on site and even a degree of water treatment, where you're pulling nutrients from the organic waste processes and selectively putting that right back into the facility, that could potentially be a far more cost-effective way to more or less do like wholesale type of trading of these resources, if it's all kind of in-house and managed with as kind of a bundled investment. So that could be dramatically reduced and actually carry into the cost of the food produced and make it more affordable for the community itself. So that's a key strategy with why there would be some degree of energy production and water treatment within the facility itself. And then from a technology standpoint, that's a really good question. Again, we're starting to see more of these commercial operations coming online. I think investment communities becoming a lot more comfortable with putting a lot of money into these type of processes. There's been some failures. There's been a number of pretty high profile companies that have gone under in the last few years. So, it's still calculated, but I mean, certainly one thing about a lot of the food types, the organic and then the hyper local, is that there's a higher markup. There's a greater market valuation of these food items. So the idea of affordability and comparing that to, how much it costs to produce this food is really important. And I think that's also why relying more aggressively on these regional greenhouses becomes particularly valuable, because that can be a strategy that really cost effectively produces a lot of the underlying volumes of foods that would need to be consumed within the community, within the city.
Thank you. We have another, it's public. Is there a possibility, sorry, from Karan Ambardikar, sorry if I don't read well the name. Is there a possibility of connecting these urban farms to relate the retail and restaurant industry, further increase opportunities for public spaces and public realm? I'm speaking in context specifically with Gowanus, says Karan.
Definitely, yeah. I mean, there's certainly plenty of opportunity to think about creative integration of green space and food systems in this rezoning plan. And I know a lot of the other areas of the AIA study has looked at some of the land use possibilities, open space, green infrastructure. So that's already being considered. And I think there's certainly no reason that all of the kind of commercial production would have to happen within a single facility. The integrated food hub is modeled. There's certainly potential to distribute that and spread it out across multiple facilities, even within Gowanus, to have a number of different ventures, create unique products for the market, and just essentially diversify the production and access a bit more. And certainly from more of the ground-based production like that, that's really more up to the property owner what they want to do at their own site. And getting to the earlier question, even on like policy, my understanding is it's essentially illegal to grow any food on a public space unless it has previous designation or recognition of being a community farm, community garden. So yeah, I mean, it's up to the community if they want to prioritize growing food versus other potential functions that they can use for open spaces.
Thank you. Have you looked at all at employment opportunities in dense farming and these new farming, techniques and contexts about what the job potential is?
Fantastic question. I didn't do a deep analysis specifically to these technologies, but from previous work of modeling some of these systems for different cities throughout the country, particularly within the kind of hydroponic and aquaponic processes, it's pretty labor intensive. Certainly, there's a movement towards greater automation to be able to keep the operating expenses down. Labor is a really substantial part of kind of urban, more technology-based production versus the large-scale monocrop like peri-urban and regional production. But yeah, certainly from a workforce development, like as an example, the agriculture opportunities model with an integrated hub for the hydroponics, the vertical farm, and the aquaponics would probably support between like 70 and 100 jobs. I believe that the Aero Farms has about 100 employees in their Newark facility. So it's notable workforce development for sure.
Okay, thanks. I know one of our students at City College also had a question, Jason Iwaneski. Wanted to know about, what statistics we have now for tracking local food production, and if we have any idea of how much we are producing now, what percentage of our food production. And I would think that might be regionally specific too within a city.
Yeah, that's a great question. I haven't seen recently. I know that about even 8 to 10 years ago, there have been some studies as far as local food access, and I haven't seen research more recently about those implications. Yet of course, that's really, really critical to be able to acknowledge just what's our starting points, what are successes that we can leverage, relationships that are already there, and resources and even just like social infrastructure that can be expanded to be able to accelerate this type of process. Yeah, I know certainly a lot of the analysis has been on local food deserts, where are underserved communities, how do we get greater access to them, and the farmers market type of information is more readily available about what type of farms are able to come in and service the city, and I'm not sure what specific volume of food consumed that would support, though. Probably very small.
We have other questions or comments that people might want to ask live.
I think Jeffrey has a question. Jeffrey, can you unmute yourself?
Hi, can you hear me?
Yes.
Okay, good. I'm sorry, I'm outside. Thanks, Joshua. Joshua, that's great. I'm wondering on the urban-rural connection with respect to circular economy, food waste, food in one direction and waste going, organic waste going to the other direction. Could you talk about potential disruptive technologies that might be on the horizon that could address this at a kind of industrial scale, at a regional scale, such as, say, autonomous vehicles or, those kinds of distribution technologies that could be brought to bear. So that's one thing. And the second is, with the movement of the 15-minute city that you're seeing in cities like Paris and elsewhere, could you talk a little bit about how food might figure into that equation? So just two things I was curious about.
Fantastic. Thank you, Jeffrey. Excellent questions. From the kind of technology related to waste and distribution, certainly a lot of innovation that's taking place. One area that I didn't really stress is within this is even the life cycle of food systems, and particularly related to carbon. And close to half of that is about the production of how food is produced. So that was kind of the key focus of this presentation. But the assumption and recognition is that through far greater localized production, you're dramatically reducing the impacts on the rest of the food life cycle, as far as the need for upstream pesticides, or trucking 2,000 miles and the carbon impact of that. And food waste would be an important factor, which could potentially be managed, industrially, even at the facilities, where there could be, site-based biodigesters that, for example, thinking about more of these controlled environment agriculture processes in the countryside, is that you could obviously process that alongside livestock, where there's manure. You could have an on-site biodigester, which then converts that into biogas and methane, and also CO2, which could then be piped right back into the greenhouse to make the plants grow faster. So there's really interesting ways of capturing some of these synergies across these systems. But I think certainly from a kind of distribution technology, a disruptive technology could be like electric trucks, like Tesla's designing those. If those become more pervasive in the future, prevalent, that could essentially have zero emissions distribution. And of course, like within the communities themselves, even touching on your kind of 15-minute walking is, if there's a localized distribution center like this food hub, then all of those sort of runs of bringing that hyper fresh food directly to consumers can be done using small scale electric vehicles or cargo bicycles, or a myriad of ways of being able to distribute to local customers. So you can really reduce the congestion that's required for moving food around. And ideally it'd be great to have a lot of these processes really be spread out within the community, so that they can interact with that on a day-to-day basis. Certainly, like, community gardens have greater benefit than just food security. There's the beautification, there's the heat island effect, there's stormwater management, there's recreation. So if there's a food culture that's very embodied and experienced within Gowanus and other neighborhoods, that would be a really wonderful thing.
Thank you.
So I know that we had a 1 o'clock stop on this meeting. I'd like to thank everyone who attended for joining us, and hope you'll continue to join us on essentially Fridays every other week. Cecilia, I'll turn it over to you to close out the meeting, or to continue it if you like.
Well, Josh, thank you for the wonderful discussion. And there's a lot of things that I think new technologies, and potentially maybe there's a future carbon tax that's coming along. Who knows what's going to happen with all of these. But I think there's going to be a lot of opportunities in this current situation. I would like to have everyone, this is the last round of call, if no more questions. And we are going to thank the speaker virtually. Let me see if there's a, right. Thank you for the wonderful talk. And we will make this video available online. And please keep the conversation going, and we will see you in 2 weeks' time. Thank you very much.
Thanks, Josh.
Yeah,
Thank you,
appreciate
Josh.
it very much.
Thank you, Joshua.
Pleasure. Thank you all.